So in this video, we're going to go through the sine rule. We're going to use the sine rule to find missing side. We're going to look at slightly more advanced examples with angles on a straight line and equilateral and isosceles triangles. And then we're going to use it to find missing angles. And then finally, we're going to finish off by looking at an exam question. So the way my videos work, I'm going to do the example on the left, which is I do. You are then going to press pause and have a go at the example on the right, which is you do. But before we start this, what exactly is the sine rule? So if you look at this triangle here, the sine rule is used to find the missing side or a missing angle in a triangle. So with the right angle triangle, you can use something like SOHCAHTOA, but when it's not a right angle triangle, you can use the sine rule. So essentially what the sine rule is saying is, if we have a side, so let's go with this side. If you have side A, we can divide that by the sine of the angle opposite that side. So the angle opposite A is that one there. So we'd say that is sine A. Is equal to any other side, which is, let's just say side B for now, divided by the angle opposite that side. So the angle opposite B is that one there. And the exact same for C. So essentially this is what the sine rule is. And we can even write it the other way around. So we can write sine A over A is equal to sine B over B, which is equal to sine C over C. So if you look at solving a question with this, so here we've been given a triangle. It's not a right angle triangle, so we can't use SOHCAHTOA to find the missing side. We've been asked to find the missing side, which is x. So does x have an angle opposite it? Yes, it does. So let's start with that. So we have got x is what we're trying to find. Using the sine rule, we can say the side divided by the angle opposite is equal to another side divided by the angles opposite that. So that's going to be 5 divided by sine 67. Now, if we rearrange this, we get x is equal to sine 54 times 5 over sine 67. And to one decimal place, that is 4.4 centimeters. So press pause and have a go at the example on the right. Again, the exact same principle again. Hopefully you've had a go at this. We're looking for a side in this triangle. This side does have an angle opposite it. So let's just write what we're looking for. You're looking for x. Divide that by the side opposite it using the sine rule. And we can do the exact same with another side. So we can see that this side has an angle opposite it. So we can do 6 divided by sine 50. And if you rearrange this times each side by sine 75, we get that. And if to one decimal place, that is 7.6 centimeters. Do not forget the units. So have a look at another example here. So the question is asking us to find a missing side x. Does that side have an angle opposite it? Yes, it does. So let's start with that information. So we have x divided by sine 80. We are using the sine rule. Do we have another side with an angle opposite it? Yes, we do. Cool. So let's just do that. And rearrange this. We have sine 80 times 3 over sine 71. And that gives us 3.1 centimeters. Again, hopefully press pause and I'd go at the example on the right. So we'll start with, well, what is it that we're looking for? It's a triangle. We're looking for a missing side x. Does that missing side have an angle opposite it? Yes, it does. So let's start with that information. We're looking for a side. So we can write x over sine 29 is equal to, now do we have another side and an angle opposite it? Yes, we do. So we can use the sine rule. And as we are, that is going to be 7 with sine 120. So essentially, you're going to move sine 29 to the other side. So you're going to multiply that by 7 over 120. And that gives you x is equal to 3.9 centimeters. Now, moving on to this one. Now, this is a little bit more tricky because you've been given an extra angle that you don't really need. So start with the exact same principle. What is it that you're looking for in the question? X. Does x have an angle opposite it? Yes, it does. So let's start with that information. X over sine 93. Cool. Now, do we have another side and an angle opposite it? Yes, we do. We have another side and an angle opposite it, which then means we can ignore the 62 because there's nothing on this side. So we don't need that to solve this question. So we can then just write 4.7 over sine 24. And now if I rearrange x, if I move sine 93 to that side and multiply that out, I get my answer as 11.6 centimeters. Again, hopefully press pause and add a go at the example on the right. So we can see that x is opposite 37. Do we have another side and an angle that are opposite each other? Yes, we do. And you'll see why I keep saying this in a second. So x then becomes 5.2 centimeters. So here's some practice questions for you to have a go at. Press pause and have a go. When you're ready, press play for the answers. Here are the answers. Mark your work. Now moving on to slightly more tricky questions. Now you'll see why I kept on saying them words earlier around angles being opposite. So we're looking for x in the question. We have been given a triangle. We can use obviously the sine rule to solve this, but let's see if we can use the sine rule to start with. What we're looking for, x. Does x have an angle opposite it? No, it doesn't. Okay, does that now mean we can't use the sine rule? Maybe it does, but let's see, what else can we do? So we can't start here because we've got two missing bits of information, so we can't really start here. But what do we know about triangles? Well, angles in a triangle add up to 180. So if that's 60 and that's 120, 50, sorry, we know that 60 plus 50 is 110. And if I do 180 take away 110, I get 70. So I know this angle here is 70. So let's write that in. So that is 70. Now let's look at the question again. We have x. Do we have the angle opposite x? Yes, we do. Let's start there then. So we have x. Divide that by sine 70. Now, do we have another side and an angle? Yes, we do. So let's write the side. Divide that by the angle. Remember, we're writing the side over the angle on each side. So if you have x is equal to sine 70 times 6 over sine 50, and we get 7.4 centimeters. I'm not writing out the whole working out here, just to speed up the video a little bit. Now, hopefully you've pressed pause and had a go at this. Again, you can't start here because we're missing something. So let's find that missing angle first. Well, it's that 70, that's 50. This must be 60. Angles in a triangle add up to 180. And now we do have an angle opposite x. So that is going to be x divided by sine 60, which is going to be, again, another angle and a side opposite each other. So that is going to be 5 divided by sine 70, which is x is equal to sine 60. So we're going to move the 60 over to the other side, multiply that out, and that is 4.6 centimeters. Now here, we've got to use the properties of a triangle. So immediately looking at this, we are looking for x. There's nothing opposite x, so we're not going to start there. So we have to take a step back and say, okay, what can I figure out in this question? So immediately looking at this, I can see it is a isosceles triangle. Both sides are the same, so I know that this base angle and that base angle are the same, which means that's 100. Angles in a triangle add up to 180, so that is 80. Okay, now let's go back to where we started. We're looking for x. Is there an angle opposite x? Yes, there is. And is there another side and an angle? Yes, there is. And x, again, you're going to rearrange that, move the sine 80 to that side, multiply that out, and that gives you 12.9 centimeters. Now, again, hopefully you've pressed pause and had a go at this. So it is an isosceles triangle. So that means both the base angles are the same. So that is going to be 65 degrees. And angles in a triangle add up to 180. So that is going to be 50. 65 plus 65 gives you 130. Take that away from 180. You get that. Again, now we are looking for x. Is there an angle opposite x? Yes, there is. And now, is there a side and an angle opposite each other? Yep, these two. So we have x is equal to sine 50. We're going to move the sine 50 over, times 5.4 over sine 65, which is 4.6 centimeters. So looking at this one now. So again, it might not be immediately obvious that you can, what you would do with this kind of question. So A, we're looking for a missing side. X, by the way, is from there to there. Okay, so it's not referring to this whole length. It's just referring to this from there to there. So we're looking for x, which is a side. So straight away you can think through the theorems in your head. Can we use Pythagoras? No, it's not right angle triangle. Sine rule, maybe we can use a sine rule. Okay, we have x. Do we have the side opposite x? No, we don't. Okay, just because we don't have this doesn't mean we can't use the sine rule. Do we know any other information? Yeah, we've got, well, that's a straight line, that's a straight line. So I know that this is going to be angles on a straight line, that's 60. That's angles on a straight line, that's 40. And I know 40, that's going to be 100. Angles in a triangle add up to 180. Now I've got that. So we can write x divided by sine 80 is equal to another side and an angle, which we do have as well. So 9. And then x is equal to 10.2 centimeters. So again, hopefully press pause and had a go at this. So we're looking for x now. the angle opposite x is that one there. And how I know that is because that's how the angles are formed, okay? So that is the angle opposite x. So it's that one there. So can we find that angle? Yes, we can. It's angles on a straight line. Angles on a straight line, so that gives me 50 degrees there. And now there is, I can find x using the sine rule. Sine 50. So now we need a side and an angle opposite it. We don't know what this angle is, but we can find it quite easily because angles on a straight line add up to 180, so that's 100. And that will become 7 divided by sine 100. And that is going to be x. And we rearrange that and we get 5.4 centimeters. Again, press pause and have a go at these practice questions. When you're ready, press play for the answers. Here are the answers. Mark your work. So moving on, now we are looking for an angle. So x is now an angle, but the same rules are still apply, okay? So we're now looking for angle x. Does it have a side opposite it? Yes, it does. So let's make a start here. But notice now what I'm writing at the top. I'm writing sine x, okay? Because we're looking for an angle, so now we're writing the angle at the top. It just makes our life a bit easier. So whatever you're looking for, you put at the top. It's got a side opposite it, which is 7. If you look here, we've got a side and an angle. So that is going to be, again, remember we are writing the angle at the top now, sine 50 over that. And now just to be a bit careful here, I'm not going to keep writing this out, but I'll write it out for this one. When we rearrange this, we move the 7 over to that side. So we end up with sine x is equal to 7 times sine 50 over 6. And then we have x. To get x on its own, we do the inverse. So that becomes sine, and then bracket 7 times 7 sine 50 over 6. That is how you type that into your calculator. And when you do type that into your calculator and you press enter, you will get a value of 63.3 degrees for the angle. So again, hopefully press pause and add a go at the example on the right. So we are looking for x. Is there a side opposite x? Yes, there is. So let's start there. Remember, it's sine x now because you're looking for an angle. Do we have another pair? Yep, we do. So let's take that. We have sine 67 over 5. And again, I'm not going to keep writing it out, but I'll write it out for this one because we've just started doing it. So that would look something like this. You type that into your calculator, you hit enter, and you get a value of 47.4 to 1 decimal place. Moving on, again, we are looking for a missing angle. Okay, can we use the sine rule? Yep, we do have a side opposite x, and then we have another side and an angle. Yep, we do, these two. So let's use that. And then x becomes 4.7 times sine 62. Divide that by 8.5. And we are doing the inverse of sine. And that becomes 29.2 to 1 decimal place. Again, hopefully press pause and add a go at the example on the right. So we are looking for x. Does x have a side opposite it? Yes, it does. So let's start there then. Since x is an angle, we are doing angle over side. Do we have another angle and a side? So yes, we do. So let's use that. Sine 42 divided by 6.2. And for x, we will have the inverse sine. 2.4 times sine 42 divided by 6.2, and that becomes 15.0 centimeters. 0.0 because the question says to 1 decimal place. So again, press pause and have a go at these. When you are ready, press play for the answers. Here are the answers. Mark your work. So moving on to slightly harder examples with finding an angle. So again, you've been given a triangle. You've been asked to find a missing angle, and if you want to use the sine rule, does x have a side opposite does angle x have a side length given opposite it? No, it doesn't. So this isn't where we're going to start, okay? Since both things are known, so we're not going to start there. We do know that on this side we have both things, which is fine. Okay, that's good to know. And with the formula, we always start with what we don't know. So since we know these two, we're not going to start here. How about here? Now, we don't know what these two are. And now you might be thinking, well, why do we need this to find that? Because remember, angles in a triangle add up to 180. If I know what this is, I know what x is. So if I now label this y, I am now going to solve for y first. once I have found what y is, I'm going to then find x. So if I say y, so we're looking for angle y, we're going to divide that by the side opposite angle y, and then we're going to use the other side that we know both bits of information on. And if I write y there, that becomes 51.20776365. And then angles in a triangle add up to 180, so that will give us x is equal to 180, take away 60 plus the 51.2 ... that we got for y, and that gives us our answer as 68.8 degrees to 1 decimal place. Now, just note here that I did keep the full accuracy because the answer is asking for 1 decimal place in the end, so you just bear that in mind. Again, hopefully you've pressed pause and had a go at the example on the right. So we are looking for x. It does not have a side opposite it, so that's not where we're going to start. On this side, we've been given both bits of information. That's good to know, but we always start with what we don't know. How about on this side? Well, we've got an angle and a side. Remember, angles in a triangle add to 180, so it might not always be immediately obvious why finding another bit of information might lead to that. So we'll label that y. So side y, divide that by the side y. It's equal to the other side, which we have been given, so that's sine 40 over 8.7. And if you rearrange that and solve it for y, we get 72.84204364. And then for x, now angles in the triangle add to 180, so that's just going to be 180 take away y plus 40, which we already know. And when you put that into your calculator, you get 67.2 degrees. So looking at this one now, again, when you look at x there, you might be thinking, well, it's not inside the triangle. So how do I find x? Well, if you look at x, it's on a straight line. Now, if I draw that there and call that y, if I knew what y was, I can find what x is. Because, for example, if y was 80, I know x is 100 because angles on a straight line add up to 180. So in this question, we're going to start by finding y. So can I find y using the sine rule? Well, what's the side opposite y? Well, we don't know it, so we can't start here just yet, okay? So if we just look at this triangle, what else do we know? Well, we've got this side and this angle. That's good to know. But remember, with the sine rule, we always want to start with something that we don't know. How about this side? Well, we have this side, and this angle's missing. Now, let's start by finding that missing angle and see if that can help us solve this question. Let's call that z. So if I say sine z, divide that by the side opposite the angle, which is 4.4, and then let's use another side that we know all the information for, that. So that's sine 60 over 4. And now if you rearrange that and solve it, you will get z as, so if I type that into my calculator, it will be sine 60 divided by 4 times 4.4, and find the inverse sine for that. And that gives me 72.2936894. And I can use that to find y because angles in a triangle add up to 180. So y is going to be 180 take away z plus 60. So if I just add 60 to that, take it away from 180, take away the answer, that gives me y as 47.7063196. And remember, x is just going to be 180 take away y. So we now know what y is. So we take that away from 180 and we get our answer as 132.3 degrees to 1 decimal place. So there was quite a few steps in that one, but hopefully that makes sense. Now, again, hopefully you've pressed pause and had a go at the example on the right. So, sometimes you can immediately see that you can figure something out, and you just should, because it could help you solve the question. So straight away, we know that 60 angles on a straight line. So here we do have x and a side opposite it. So if you just use that, sine x and a side opposite. And do we have another side and an angle? Yep, we do. We have that. So let's just go with that. Sine 60 over 8. If we now rearrange and solve that for x, we get 54.3 degrees. And finally, we are going to look at a slightly more advanced example. So in this case, again, like I said just now earlier, if you can look at a question and figure some things out immediately, it might not be obvious why you need them. So for example, to find x here, it might not be obvious exactly what you need. So for example, you need that angle there, but you don't have it, right? So we know angles in a triangle add up to 180. So we know what this angle is. So that is going to be 70. Well, we know that this is angles on a straight line. So we know that this is going to be 110. So at this point, feel free to press pause and have a go at the rest of the example yourself, or you can just watch along. So, okay, so now that we do have this information, we have x and we have an angle opposite x. Okay, so we can write that out. We have sine x. No, not sine x. It's side x divided by the sine 10 is equal to now another side and an angle in that triangle. Now, in this triangle here, yes, we do have an angle, but it's missing a side. And if you look at the other side, we have nothing here and nothing here, so we're not going to use that. So we know now to solve this question, I need to know the length of this side. Now, I can't find that using this triangle here, but can I use this triangle here to find it? So let's label that side y. So we are now looking for y. We know y has an angle opposite it. So let's start with that. So we have y over sine 80. Now, do we have any other side and angle in this triangle? Yes, we do. We have got this. So if we go with that, that is going to be 8 over sine 30. So we have y is equal to 15.756924. Cool. So we have got that. And now, if you come back to this, I'll write it down here. We have x over sine. And by the way, it's fine to do something like this and stop. Because when you look at that and you stop, you know, actually, there's something I need. I need to do something else in order to, you know, completely write this, because there's not enough information. So that's why we then started focusing on this triangle. So if I now come back to that, because now I do have enough information, because I've got y, and y is opposite that. So I can completely write this now, because this is y divided by sine 50, right? And now I know what y is, so I can just write that in. 6924. And we have x, and that turns out to 19.3 centimeters. And here's a final set of practice questions for you to have a go at. Press pause and have a go. And here are the answers. So if you found that video useful, please consider subscribing, and as always, I'll catch you in the next one.